In this class, let us see how to find the inverse of a non-singular matrix using Gauss Jordan method. Now, this method is based on this definition of the inverse. Let us assume A be a square matrix of order n, which is non-singular, and there exists a matrix B such that AB equal to BS equal to I. Then we can say that this B is nothing but inverse of A and is not by A inverse. This is the definition of what inverse of a matrix. Based on this concept, let us find the inverse of non-singular matrix by Gauss Jordan method. Let us see how to find this one. See here. If you take a matrix A, this won't be changed if you multiply this matrix A by an identity matrix. This A can be written as I into A. Now, based on this concept, we can find the inverse of this non-singular matrix. Now, before that, let us recall the row elementary transformations. First, let us see that one. See, if you consider two matrices A and B, if these two matrices are equal, then you want to perform the row elementary operation, means you can perform in both these two matrices simultaneously. For example, if you take that is A, B, C, D, and this matrix B equal to A1, B1, C1, D1. If these two matrices are equal, if you want to perform elementary operation, means we can perform the row elementary operation in both these two matrices simultaneously. For example, if you want to find a new R1 as R1 plus R2, means we can easily do it. That is A plus C, here B plus D, and here C, D. We can write. Here also we can write A1 plus C1, here B1 plus D1, here C1, D1. Likewise, we can do our operation on both the sides simultaneously. Suppose instead of these two matrices A and B alone, suppose the right hand side is given as the product of two matrices. Given as the product of two matrices. Listen here. If we take A is equal to B into C, if you consider A equal to B into C, then if you want to perform any row operation, means here we can do it directly. Row operation can be done in the matrix A because we have only one matrix, whereas in the right hand side we have product of these two matrices. In which matrix you have to perform the row elementary transformations, means you can perform only in the first matrix B, because always when you multiply two matrices, we have to take the product of the first row elements with this column elements. Therefore, always you are going to consider rows in the first matrix only. Therefore, we have to perform row elementary operation only in the matrix B. For example, listen again in the previous case, that is A, B, C, D. This is one matrix. Then another matrix is E, F, G, H. Into the C matrix can be written as I, J, K, L. Just I have written for example. Okay. Now, whenever you want to use the same elementary operation, what you have done in the previous case, R1 gives R1 plus R2, means here left hand side we have only one matrix. Therefore, we can perform the row operation directly. Therefore, this can be taken as A plus C, then B plus D, then C and D. Left hand side, okay, no confusion. But right hand side, we have two matrices, means in which matrix you have to perform this operation, means only in the first matrix B. Here you have to keep this matrix as such. You should not disturb the elements of this one, because always used to take row by column operation. Whenever you are doing column operation, you can use second matrix. Suppose you are using row operation, you have to use only the first matrix. Therefore, here you can take E plus G, then here F plus H. Then you can write G, H. Then into, you can write the other matrix as such I, J, K L. Listen here, we did not do any operation in the second matrix because we are using row operation. Therefore, this concept is very, very important when you have product of two matrices. Based on this concept, he has introduced a method to find the inverse of a non-singular matrix. Now let us see how to perform these things. So here, as I told, if you consider matrix A, if you multiply this by an identity matrix, this is not unaltered. A is equal to I into A. Now here this Gauss Jordan introduced a method by applying row elementary transformations in the matrix A. You want to convert this matrix A into an identity matrix. Any matrix, suppose you have A, B, C, D means by using elementary operations you can get an equivalent matrix that any matrix can be converted into what? A unit matrix. That is, you have to change this 1, 0, 0, 1. This matrix is to be converted into a unit matrix or identity matrix. Now likewise these things can be obtained by using only row elementary transformations. Therefore here this A must be converted into identity matrix by applying row transformations. Therefore, this by applying row transformations, this matrix A can be converted into I matrix. While applying row element transformations, in the right hand side we have product of two matrices. Here we can apply row elementary transformation only in this matrix I. Now if you apply element transformations in this matrix 1, 0, 0, 1, so this will be changed into some other matrix A, B, C, D like that if it is 2 by 2. Therefore, this identity matrix, if you apply row element transformation, you get another new matrix. That matrix can be taken as B. Now this A won't be disturbed. This you can write as such. Now this A equal to IA becomes I equal to BA by applying the elementary transformations. Hence, here the product of BA equal to I means, already you have seen AB equal to BA is equal to I means we can say B is nothing but what? Inverse of A. Therefore, based on this concept, if you multiply B with A, you are getting I means we can say this B is nothing but inverse of A. B equal to inverse of A. Now, this is the method introduced by Gauss Jordan. Hence, this is. Let us see our book method. This is actual method. Now, let us see what is book method. The same thing. See here, in this matrix A, we are augmenting with this identity matrix of same order N. Now, by applying the row elementary operations, we are going to convert this matrix A into the identity matrix, and this matrix identity matrix becomes some other matrix B. Now we can say this B is nothing but inverse of A. That is, we can write A bar IN. This is augmented matrix. Now we are going to convert this as IN, and we are getting a new matrix called B, which is nothing but inverse of A. Therefore, we can write A inverse. Now this is the method given in our book. Now we can augment A matrix with identity matrix, and now by applying elementary transformations, you have to convert this A matrix into identity matrix. Then automatically this matrix will be the inverse of A. Now let us see how to find this inverse by this method. This is first solution of the third problem given at the page number 27 of exercise 1.2. In our material, this is problem number 14. Now for this matrix we have to find the inverse by using Gauss Jordan method. For that, let us assume the given matrix as the matrix A, that A equal to 2 minus 1, 5, 2. Okay, now we have to find the inverse for this matrix A means first we have to consider the augmented matrix. The augmented matrix is A bar I2. yi2 means this order 2 by 2 is equal to, see, a is 2 minus 1, 5 minus 2. Now, this we are augmenting the ID matrix 1, 0, 0, 1. 1, 0, 0, 1. Now, our aim is to convert this matrix into identity matrix. Convert into which matrix? Identity matrix of order 2, and this matrix will become inverse of A. Now, here we are not multiplying, therefore this augmented matrices we can apply row operations simultaneously for both I2 for this matrix and also for this matrix. Now, want to make this as ID matrix means first concentrate on the first element. This element must be 1. Then this also must be 1. This must be 0. This must be 0. Therefore, to make these diagonal elements as 1 and these anti-diagonal elements as 0, you can use only row elementary transformations. You should not go for column elementary transformations. No. Now, want to make this as 2 means now we have to divide the first row by 2. Therefore, you can divide the first row by 2. R1 gives R1 by 2. Therefore, this becomes 1. This becomes minus 1 by 2. This becomes 1 by 2. This is 0. Now, this also, see here, you can take 5 minus 2. This is 0, 1. Okay. Now our aim is to make this as 0. That is, you have to make this as 0 to bring the into identity matrix. Therefore, first we have to make this 0. Now this is equivalent to, we can write R2 gives R2 minus 5 times R1. Therefore, we can write R1 as such 1 minus 1 by 2, 1 by 2, 0. Now here R2, what is R2? 5 minus 2, then 0, 1. Now you have to multiply the first row by 5. That is, you can write this is 5, this is minus 5 by 2, this is plus 5 by 2, this is 0. Then you try to subtract. 5 minus 5 becomes 0. Then this is minus 2 plus 5 by 2 while subtracting. That is, this is minus 4 plus 5 means 1 by 2. This gives 1 by 2. Now next term, here 0 minus 5 by 2 gives minus 5 by 2. Minus 5 by 2. Then this is 1 minus 0 gives 1. Okay. Now after making this as 0, want to make this also 0. If you add these two things, this will become 0. Therefore, we can write R1 gives R1 plus R2. R1 plus R2. Therefore, we can write this as 1 plus 0 gives 1. Minus 1 by 2 plus 1 by 2 gives 0. Then this is 1 by 2 minus 5 by 2. 1 by 2 minus 5 by 2. You are adding. That is, this gives a minus 4 by 2 means minus 2 you can get. Minus 2. And by adding these things you can get 1. Now, the second row you can write as it is 0, 1 by 2 minus 5 by 2. This is 1. Now, almost we are reaching the identity matrix. Here, this are to make this as 1. Therefore, this expression is equivalent to, you can write R2 gives 2 times R2. R2 gives 2 times R2. Therefore, first row you can write as such 1, 0, minus 2, 1. Then if you multiply this by 2, you can get to 0, and this is 1, this is minus 5, this is 2. Now listen, this first matrix 2 minus 1 5 minus 2 becomes 1 0 0 1. Therefore, by Gauss Jordan method, we can write this as I2 augmented with A inverse. I2 augmented with A inverse. Therefore, this matrix can be called as A inverse. Therefore, A inverse is equal to minus 2 1 minus 5 2. Now, this is called the inverse of A. Now, you know very well, if it is 2 by 2 matrix, we can directly find the inverse of A by using the formula 1 by determinant A into adjoint A. 1 by determinant A into adjoint A. Here determinant A means minus 2 plus 5 gives 1. Therefore, 1 by 1 gives 1 only. Now, what is adjoint? If it is 2 by 2 matrix, interchange the diagonal elements minus 2 and 2. Change the sign of the anti-diagonal elements 1. This is minus 5. See here, minus 2 1, minus 2 1, minus 5 2. We got the inverse. Therefore, this is another method of finding inverse of a non-singular matrix using Gauss Jordan method. Now, this is about lengthy. In how to find the inverse of a 2 by 2 non-singular matrix only. In the next class, we will see how to find the inverse of a 3 by 3 non-singular matrix. Now, let us see in the next class. Thank you, children.